Evening guys, today we are back with another problem, and today's problem is finding the kth smallest element present in an array. So this problem statement is pretty simple problem statement, but before I solve this problem statement, make sure make sure make sure you go and like and share and subscribe to this particular channel, and it will help me grow. It will help us solve more difficult problems into easier and simple problems. Okay. So let us first analyze. It is saying that given an array and an integer k, where k is the smaller than the size of the array, the task is to find the smallest element in the given array, and such that all the elements are distinct. Okay, don't use any inbuilt sort function. Okay, so say for example, if I am using a bubble sort, because it is saying we cannot use we cannot use inbuilt sort function. So let us try with a bubble sort. Okay, a bubble sort. So if I'm using a bubble sort, what is the logic which I will be using? Say I'll be using I equals to 0, say I less than n, I plus plus, okay, and for int j equals to 0, j less than n minus I minus 1, j plus plus, then arr of j temporary equals to then arr of j equals to arr of I, j, j, I, arr of equals to temp, and what I can do is I can return a k minus 1. Okay. So now if I check this particular solution, what I did, I took in a temporary variable. Okay, so this thing will be array of j equals to array of j plus 1, and array of j plus 1 is equals to 10. Okay, so here if I'm doing this and if I'm running this particular problem in bubble sort, what is the solution I will get? Here what I'm using, using two loops, right? See, it is running, but I have to submit the solution. And when I'm submitting the solution, what I'm getting is all the test cases are not passing, and it is taking some more amount of time, probably because of the time complexity issue. Okay. So now if I do this change, if I just write over here arrays dot sort, and I pass the array, okay, then I am submitting it. What is the error of k minus 1? So whenever you are sorting something, it will be sorted in a particular manner, and the problem will be solved. And k minus 1 is basically the element before it. So if I am having 7, 10, 4, 3, 20, and 15. So if I am sorting this using, say, any sorting technique, so what I will get is 3, 4, 7, 10, 15, 20. Now my k value, assume my k value as 3. So what is the third smallest element? What is the third smallest element? The third smallest element is 7, right? But how I'm going to return the 7 value? So when I'm numbering these elements, so I'm following a 0x indexing. So if my k is 3, then I'm returning k minus of 1, which makes me come to this particular position. This is my actual position. That is how I am getting my kth smallest element. Okay. Now I'm going to experiment and try how I can solve using some other technique, not the inbuilt function, and follow the adequate time complexity. Now we will be implementing another technique which will help us to solve the particular problem in the time complexity, in the given time complexity of O of n plus 1. Okay, O of n plus 1. And how we are going to do this? So we'll be implementing a technique called counting sort. So if we solve this using a counting sort, our task will become very, very easy. Okay, so let us understand the process of counting sort. So the first task is we have to take the kth smallest element. So this is our function. We are taking the array and the k value. Now first is to find the maximum. So this is a very simple and basic task we all know, finding maximum element in array. Okay, so when I'm finding the maximum element inside an array, what I'm doing is I'm taking a max value. If my present element is greater than the max, then I'm updating it with the max value. Now we are going to count array to store the frequency of each element. Okay, kind of like the hash map. In hash map, we take a particular key and a value. So value and key help us to count the frequency. So in this array, in the counting array, we are going to store the max plus 1. Means we are going to store the maximum value plus 1. Okay, that is the length of the array. So the length of the array is maximum value plus 1. Okay. Now fill the count array. So inside the count array, we are going to fill the array with the numbers. And where are these numbers? Numbers are basically present inside the array. Numbers are basically present inside the array. In our case, if we have 7, 4, 3 and 10, so we are going to fill up the array using 7, 4, 3 and 10. But before that, we are getting a value as 10. We are getting a value as 10, then our array size of the count array, which is going to store the frequency, should be 11. The length should be 11 because 10 plus 1. Now we are filling the count arrays. Okay, we are filling the count arrays, and when we are filling the count array, we are also taking the numbers. So say for example, whenever I'm encountering a value, I'm going to keep the count of that particular value. Now we are finding the kth smallest element, so this is counting sort. We are sorting it with the help of the frequency of the occurrence of each element. So we are taking a variable cumulative count equals to 0 from 0 till the maximum element. Whenever the cumulative count is updated with the count of I. Okay, so say for example, a particular value, say for example third smallest value or fourth smallest value, we are updating it similarly like that, and the value should be greater than equals to k. Value should be greater than equals to k, which signifies that suppose our value is 3. Suppose our value is 3, k value is 3. So our cumulative count should be either 3 or 4 or 5, any greater values. Okay, and lastly, we are going to return the index. So this was all about counting sort, and we can return the index. Okay, so now we are if we are executing this particular problem statement, if you see the O of n plus max element. So whenever time complexity is given to you in the question, like this, O of n plus max element. Now, where in earth do you solve the problem using a bubble sort? There is no concept of max element inside a bubble sort. There is no concept of max element inside an insertion sort. So the only concept which uses this is counting sort. So this is how you have to identify. Your question will be how I am going to identify whether I have to do this using counting sort or bubble sort or inbuilt function. The time complexity will be given in the question. When it says O of n plus max element, so O of n, we are getting it O of n order by filling the array. And max element also, we are finding the maximum element. So now you can understand that first we are traversing, our loop is traversing till the from 0 to the total number of elements plus the maximum element. Okay, so this was today's problem statement. Make sure you like, share and subscribe to the channel. Thank you so much.